Hello, and welcome to this video attempt at romanticizing maths. If Twilight, 50 Shades, and Hancock pass as some sort of Hollywood romance, then maths has tragedies of a Shakespearean caliber. These are three of the best. Tangent lines. These are 2 points which intersect at only one point in space, and then never again, in a way like Romeo and Juliet, who met and were then dead. Unlike parallel lines, which always run a course next to each other, they may be a hair's breadth apart, or fathomless distances, but this separation will never change. They'll be forever separated. They will always be the same distance apart. Asymptotes are almost the opposite in nature. As time or distance increases, they will get closer, but yet again, never touching. The name even means to not fall together. These three could well put almost anything made by Hollywood over the last 10 years to shame. Their downfall lies in their lack of characters, development, or even the remotest trace of humanity. Although tragic, these three are entirely symbolic. There is one real-world example of a tragedy in maths that supersedes them. That is the proof of Shinichi Mochizuki, an ingenious mathematician whose work everyone yet sees as something of an enigma, but holds tantalizing fragments, promising rich rewards to whoever can grasp it. What this has in common with the first three tragedies of maths is how the author has transformed the problem into graphed elliptic curves, whose appearance crosses the axes at points that are known. This is about his proof of interuniversal take-mother theory. This is a mathematical paper spanning 500 pages of core work and a further body of reference material. This is said to contain a way to prove the conjecture of A plus B equals C, adding that C is greater than D. To drastically oversimplify this deceptively simple equation, A is the first prime number in your sequence, B is the second prime, and C is the sum of these. There is another factor for this conjecture, and this is C, which is greater than D. D is the sum of the multiplying prime factors up to the highest of your numbers. The crux of this is how his work has been examined by a growing body of specialists in number theory since 2011. Although there was a small change which bridged a gap in 2012, there has been difficulty in understanding and progressing the work since. 6 years of review, discussion, and conjecture, but no progress yet. Few have identified unbridgeable gaps in his work in this time. Some will openly state they believe it to be correct, and there have even been some very high-profile criticisms, the most significant of which come from Scholze and Stix, details of which are in the description. But this is a story of an ingenious mathematician who has written something that goes above the heads of many peers. With time, it may yield important implications as the complexity is peeled away. Unlike the three mathematical concepts at the start, which are immutable proofs, this work is simply beyond the scope of anyone but the author for now. Mochizuki's work is like all three of those proofs. Some mathematicians have found it and left, never to come again. Others look, learn, and understand, but never come closer. And some work on it, never quite reach the conclusion. The A plus B equals C proof is important, as you can backwards calculate this equation and begin cracking some of the most common encryption key systems used for cybersecurity, among others, if this proof holds true. Thank you for watching this video. If it has been of interest, consider liking, sharing, and subscribing. Please post any comments, questions, or suggestions below.